Is my screen visible, right?
Yes.
Should I begin?
Please, you can start, Shantanu.
Okay, great. So, who can tell me what is 1 plus 1? Actually, the answer is it depends. If the first one stands for HPE, Hewlett Packard Enterprise, and the red one stands for Gurobi, then the value of the partnership is actually infinity. Hi everyone, this is Shantanu Sinha reporting from Hewlett Packard Enterprise, Bangalore, and I'm going to talk about that digital transformation journey, the journey towards infinity in partnership with Gurobi. Few lines about myself. I come with 18 plus years of industrial and research experience. Currently, I am working as a lead data scientist in Hewlett Packard Enterprise. Successfully have led several large-scale global transformation project to bring in tangible improvement in top and bottom lines. Academically, I hold a PhD in industrial engineering and operations research. So, talking on the agenda, today's agenda, there could be only two possible agendas. Either we talk something worth listening or we do something worth telling. So, for today's purpose, I'm going to take the second agenda. We already did a digital transformation journey, finished it successfully. And my primary objective is here to share with you all that digital transformation journey. But before I do that, I'd be spending few minutes on giving some glimpse around my company, Hewlett Packard Enterprise, and its vision. Then I'll talk about the digital transformation team where I belong to. And then finally, I will get into the case study, today's case study, right? So let's get begin. HPE, we all know it that popularly HPE, Hewlett Packard Enterprise, we are an edge to cloud company. So what it means that we capture the data right at the point where it gets originated. That means at the edge, the customer's edge, maybe the IoT devices or any smartphone devices. And from there, we maintain it till the cloud. The entire hardware, software, everything is our focus. That's all about the Hewlett Packard Enterprise. But whatever we do, it starts and ends with customers because we can't go too far from the customers. In fact, today's case study is also I'm going to talk about from the perspective of our customers. And we can't actually afford to lose our focus on them. Now, where I come from a team called Digital Transformation Team. The digital transformation team is actually the enabler. It works in horizontal, cut across all the functions of supply chain, right from order or quote to cash. Quote means the point where the order gets originated till all the transformation that it goes through. For example, the order is received, then the order is converted into a work order, then that work order is fit into an MRP system. From there, the manufacturing or production happens. After the production, it gets into the logistics and finally getting into the invoicing mode. And on top of that, we also touch base with one more important function, the procurement, as well as the sourcing, engineering, research, almost each and everything. So we have our presence of almost everywhere. Now, within the digital transformation team, again, we have got a few of the things different groups, advanced analytics. We work with other groups also under the broad umbrella of digital transformation, data engineering, visibility team, RPA team, data enablement team. So I primarily belongs to the advanced analytics part. And within the advanced analytics, we actually solve the problem, the large scale problem in conjunction with different departments, groups, SMEs, and the actuals. So most of the cases, whatever we do actually gets into the project mode or the live mode into the business. So that's quite a bit challenging role because we have to take care of building complex models and also host it live on ground. You can get to see the impact right on the next day and keep on monitoring or changing the model on a daily basis, on a weekly basis, or as and when it's required. So that's typically what the team does. And today, I am actually representing the whole team with this thing. So now let's get into the project perspective. Okay. Before I actually get into this, I still actually feel the old days when you actually got into this project mode. That was 2021, while the whole world was under the hood of masks and was trying to somehow cope up with the challenges that the global pandemic has thrown on the entire mankind. Here in HP, specifically the digital transformation team, had one more problem to solve. And the problem was the shortage of the materials. And I'm sure that everyone can understand and link it contextually that COVID was not a threat to human mankind, but at the same time, it disrupted our life in all possible ways, including the supply chain. Several disruptions happened and impacted so many industries. And we, the HP, were also not an exception. It hit us badly. How badly? Yeah, our supply chain was disturbed, disrupted. There is, and actually, we are into high tech business. There are specific parts or the raw materials, the raw components, the chips typically, the ICs typically, some of those very critical components are very niche parts. And those were manufactured by only a certain group of manufacturers. They all had to shut down their operations, the business. And as a result, our customers order unfulfilled customer orders got piled up and we were having an acute shortage of materials. The management doesn't know what to do with it. The customers keep on checking, where is the material, where is my order, and we didn't have any answer to them. So our leadership was thinking, what best to do to combat this situation? Yes, we know there is a material shortage. Yes, we know that there are piled up customers, unfulfilled customer orders. But what best we could do? So actually, the team was tasked to make a solution to mitigate the problem. It was around 2 years back. The journey started from there. So the team was formed. A lot of SMEs, subject matter, a lot of SMEs, business advisors, our leadership team, data analytics, the data engineering guys, all made into a solution team. And then we dive deep into understanding the root cause of it. Of course, we know that there are a couple of the problems. For example, there were not enough material, but even whatever materials were available, what is the best way to utilize them? That was the next kind of question that we are trying to answer. And when we dive deep, that we found that actually there are other challenges also. For example, HP's supply chain is very complex. A lot of things got outsourced, and it's actually a global business. We have got hundreds of stakeholders, if not thousands, and it's very difficult to get an unified view of all of them together. So that was the first thing that we figured out to solve it on priority. That means we need to figure it out a way to consolidate the most real-time information available to us. And once that is available, then building sophisticated model to figure it out what is the best way to tackle the problem. And we also started that what is the global best practices, so how the order allocation problems or the material allocation problems to the customers orders are done industry wise. What is the best practices around them and what we could do around that. And we saw that interestingly a lot of cases the most preferred or The most popular way to solve it is like following a FIFO model, the first in, first out. Or there are some order rule based system depending on the customer's request. And there are, of course, the process is like MRP. But he found that under such shortage situations, the MRP cannot handle or do a good job. Half the time the materials would be allocated suboptimally. That means the material is allocated in a way that the order can't fly because it's an incomplete order. We need few more materials, but because the material is not there, the order cannot fly. So ultimately, that material is actually blocking other orders which actually can fly. So this was some of the nuances we figured out. On top of that, there were challenges like the demands are also quite different in different regions. And I already said that it's a global problem. Each regions had their own way of solving or kind of managing the orders, right? And the customer's expectation was also grown up hugely. They wanted their materials a month back, but because of the shortage, they didn't, and they are creating a lot of pressure. And we also feel very bad, as I already said, that we are one of the most customer-centric companies in the, and we are trying to cater our focus only on the customers. So we felt really bad. So there we figured out that if we solve this particular problem, we have to actually do some bit of mathematics because it's not a simple thumb-based or rule-based system. Neither it can be solved using only MRP way. We have to build an efficient, intelligent model around that. And the method is going to be whatever supply is with us and whatever demands to be fulfilled, let's allocate them in the most customer-centric manner. What it means that let's try to maximize the customer experience. Along with that, also keep the other supply chain metrics in mind. For example, inventory or utilization of the materials. So those were our primary objective, and we wanted to meet the customer experience to the maximum extent possible. Now you might ask me the question that how do we measure the customer experience, because that's a very fuzzy term. Absolutely. So how do we model that? Well, so the customer experience actually is further modeled into few different ways. For example, the NPS or their delivery, right? If a customer has placed, say, an order which requires 500 units, and we could, and they have got a requested delivery date. So if we could deliver them 500 units by that requested date, obviously we could expect to see an impact on them. So this is obviously qualified as one of the matrices. But at the same time, you also think about our delivery cycle, the time to fulfill the customer orders in the minimum lead time, right? The turnaround time to minimize that one. So there are some metrics that we internally figure it out were termed as customer centric matrices. And then we build a very generic optimization model. And while we build that task, it was not an easy task because it's not just like building a few mathematical formulas and linking it and then deploying. It's not. It's more complex. There has to be a foundation, and the foundation was basis the people, process, and technology. And that is, I feel that one of the most complex challenge if we want to deploy any OR model on ground. The challenge is quite insurmountable. It's very difficult. But now, in order to formulate that one, we had to set up a larger collaboration with the business teams to understand what is the process. We had to get the people from different teams, for example, the fulfillment team, the planning team, the forecasting team, the sourcing team, each and everyone, and also the engineering team, because they could suggest if a part is not available, what is the best alternate parts to use. And that logic will fit into our solution. And of course, the technology. Why? Because at the end of the day, we want to host it for all our customer base worldwide. So that's how we have initiated the journey. And our focus was to bring a tangible transformation around the customer or the order management process that could potentially improve the experience of the customers, and at the same time will deliver superior business performance, the supply chain metrics. So those were the two critical points. Now, getting into a bit more details around that, how it was built. I am sure everyone has built an optimization model here, quite complex model. Same thing goes here also. So we figured it out. What are the different things that the business is looking for? We made a list of all the data requirements. We made a list of all the potential business conditions, constraints, and at the same time, we kind of made a global agreement that what should be the order management strategy. So we got started first setting up a worldwide governance team. So the worldwide governance team actually talked to all the regions and they figured it out. Hey, this time the material is not available in full. We have got a plenty of orders. Now let's make a worldwide uh, process how to prioritize and how to set up the overall objectives. And that's how everyone in the fulfillment got aligned at the first place. So we have collected all the business requirements, and there were thousands of business requirements. The order has to be followed on a certain sequence. There are bigger orders. There are different types of the orders. Some orders definitely need reservations, and they don't want to fall into an optimization so that in case the optimization engine doesn't allocate them, uh, they are not allocated. That kind of things is least expected to happen. So there are different priorities of the order. So here is a glimpse that what are the different data points we considered at the first place. Starting with that, the order data, different types of the order, they got their priorities. Then the delivery priority. There are some, all orders are important, but some orders are more important than others. For example, if it is a COVID related stuff, then we have to prioritize it because that's a question of human life, right? So we had to prioritize those order go first. So the model should take care of that. Then not all the orders are split order. That means in most of the cases, probably you also have this experience. Once you order something from Amazon, say you have ordered the both a TV and a remote control. But if the TV is get delivered, but the remote control is not, then actually it's not of any use, right? So the same thing, there are a completeness flag. That means this set of orders should be delivered together because that's how the whole order is set up. So you have to pay respect to that. Then customer requested date, very, very important matrix. Each customers has their own way. So we made a plan saying that, okay, so if some of the customers had their orders, say after 3 months, their requested date is 3 months. So probably we can put them in back burner because more priority orders where the customer is requesting right today or next month would get a precedence. So that logic also we put it. BOM, the bill of materials, is another very important matrix. And the bill of materials means the order could be at any stage. It could consume level 0 parts or level 1 parts or L6 parts. It could be a semi-finished parts. Lots of complexities came up. Customer priority. Then on the inventory, we have got some visibility. We have also got some visibility on the supply, which is on ground. So we have to consider those one. Business scope, again, as you could imagine, there are hundreds of business conditions. We have to respect them. Then order type, then lead time, because once the order is placed, of course, we need to think about their manufacturing time, their complexity time. Some orders are very easy. For example, BTO, the build to order, versus a CTO, the configure to order. The BTO products usually take a few days to manufacture, while CTO or complex CTO takes longer time. Now, if it takes long, how do we prioritize this so that it finishes just on time and can be delivered still on the requested day? That was the challenge. So all these things we have meticulously studied. Further thing is that all the business conditions, the planning horizon, the materials, their shortage duration, customer operations, and again, there are a lot of commitments which you already made to the customers. You have to respect each one of them. So, in a nutshell, those were all the details around how complex the model was there. Right, it was a massive, and on top of that, we built off a and MILP, the mixed integer linear programming. To give you a quick sense on that, again, this is just to a simplified view of that. So we wanted to maximize a certain objective function. Now we could relate it in this way that the all the x or y or basically sorry the c term is like an utility function. We could think of that. It could be the customer experience, right? Like that. So those were formulated, and the variables we consider whether an order is going to be allocated on a day or not, the quantity of the materials that we are kind of using it, the which source of the materials to use it, which date to use it, and the all sort of things, right? And then supply on the constant side, again there were a lot of constants on the supply chain side. For example, the demand supply, right? Then the customer requested date, the bill of materials. There are also some mathematical constants. For example, you could imagine that it's a flow balancing. If I take up 1 unit, my inventory is getting reduced by 1 unit. So that flow equation has to be constant, and the constant should take care of that. Plant capacity, multi-part, one order can be manufactured in multiple plants, right? And on top of that, there are a lot of logical constants. So we have spent meticulously at least a couple of months of time to model each and everything. And again, the objective was to make this model live on ground. And we have actually got the plants covered worldwide, and each plant differs on their own way. What it means that each model was uh, done separately and exclusively for certain plants, keeping in mind. So if we have deployed it for, let's say, 10 plants, we had to create 10 different MILP formulation. And not only the formulation, the overall architecture to deploy them on ground. Now, how those things were deployed? The deployed was also a bit challenging, and we have used the state of the architecture because ultimately there are a lot of people, lot of users who would be using it days and nights. And first of all, we created a guidance to gather the entire data in one place. That itself was a huge challenge. We have used the latest technologies, this is the API, to get a near real-time visibility on the data, demand data, supply data, and everything was hosted on the Azure platform. On top of that, we have built our mathematical model, hosted it there in partnership with Gurobi. So the Gurobi engine and everything was containerized, and there was a front end, and the front end again was equipped with the security system, the authentication system, and a self help or the self explanatory or easy to use UI basis the React technologies. So we have baked each and everything from the right from the data capture to the end consumption. And once the results are generated, as you could see that whoever is running or in charge of running the plant specific execution, he or she will just gather all the data in a clicks of a button and then run the model almost real time, get the output. The output is saved, and that output is going to say that, hey, this is the actual way to maximize or utilize your material. So do it, follow this way. And that was shared back to the end customers, I mean, the plants. The plants actually executed that. The feedback was provided to the next day. Why? Because we know the next day, the same order which got allocated yesterday shouldn't show up in the next day because we don't want to make a change, and the dates and things whichever committed to the customer should not also be changed. That was also big concern. So it was the multiple time period model which were deployed successfully. And the deployment, we started with one plant. I still remember it was early 22, just a year back. And then it was a big hit right in the first attempt itself. It has significantly reduced the customer backlogs in a in a in a significant way. And then everyone wanted that model to be deployed, so we the team was actually tasked to solve this one. And we had to solve it in, say, a couple of weeks of time. For every plant we were given just a couple of weeks of time to deploy it, and within that two or couple of weeks of time we have to formulate their business processes and work with the IT team Data engineering team got it deployed and get the business sign off, and that's how the whole deployment happened in a relatively couple of quarters of time. And today, when I talk about it, I still remember the benefits or the things that I definitely want to call out. Again, uh, as you could imagine, that we have got a business. It's $1 billion industry. We have the customers, and right now today, uh, a sizable parts of the customer orders is run by this model itself. So you could understand the volume that this algorithm is processing on every day. I can now talk about some of the tangible benefits that we have got it, and the numbers are still counting. So till date, we have seen that actually, had you compared the simple MRP process, which is the usual process, we have actually got a 48% more orders shipped by using this algorithm, the MILP algorithm, worldwide till date since its launch. Then 44% more orders actually met the customer requested date. Then the cycle time, placing the order to the delivery, actually reduced by 42%. Inventory reduction reduced by 34% inventory reduction. How? Let me give you a simple example. Imagine that there is an order, and that order requires 100 units of a part, and the part is available only 99 units. So what will happen? The order will not fly, and that 99 units will occupy the inventory, right? Very simple. Now here in this model, these 99 units are catered to fly a lot of orders together so that all the 99 units are being consumed. Yeah. So that's how this MILP formulation is working and bringing in tangible benefit in terms of reducing the inventory also. And today, actually, it's a huge 33, 34% reduction. Productivity also improved by 50%. Productivity means earlier the data capture was somehow a bit difficult, but now everything got automated. No touch run. The MRP process and things also got quite simple. And anybody who has gotten access to our tools and to our UI can log in, simply click a button, all the data is stored automatically, get fetched, run the model. So that eventually saves 50% of the time, and that's a huge impact of the entire process, right? So now we are seeing that the journey has just started. We have already got a taste of the success. Now we are further augmenting it. How? So we are extending our model to consider the entire portfolio. What it means that even if it is a non-sort part or the part is available in plenty, we are trying to utilize that plant. So that means we have extended the scope of our model. Secondly, we are introducing it to the supply planning. That means, on one hand, it's going to advise the planners, the supply chain planners, to make some strategic and tactical decisions on when and how much to procure and which orders to cater. And that would be linked till the fulfillment. So planning, strategic planning and the operations planning both are linked together in this way. We are also building a multi-echelon inventory optimization into the current scope. And at the same time, we are tasked by our COO to increase the coverage for few more plants. And at the same time, adding multiple plants together. That means each plant can actually borrow materials from another parts. So that's a huge transformation journey that we have already accomplished a lot in the last couple of years, and we are still continuing. We are making our models more elaborate, more comprehensive. At the same time, we are adding on more functionalities into it, and the journey has just started. I'll keep on updating as and when we get the newer success and keep the next part of the story until next time. So thank you very much. If any questions, I'd be happy to answer.